In the last lecture, we have seen how to solve the first order, first degree differential equations by using the methods variable separable type, homogeneous and non-homogeneous differential equations. So fourth type of first order, first degree differential equation is exact differential equation. Okay, exact differential equation. So when we say the equation is exact, a differential equation of the form m dx plus n dy 0 is is said to be exact if its left hand member is the exact differential of some function u of xy. That is du stands m dx plus n dy 0. Its solution therefore is u of xy is 0. Means, for example, if you take a function u is equal to xy, then du means the total differential of u. Total differential of u is dA by u by dA by x dx plus dA by u by dA by y dy. It is in this way. So what is meant by dA by u by dA by x is y. So y dx plus x dy, and equating it to 0, we get a differential equation called the exact differential equation. So there is one theorem when this equation is said to be exact is the necessary and sufficient condition for the differential equation m dx plus n dy is equal to 0 to be exact is dA by m by dA by y is equal to dA by n by dA by x. Okay. Now we are not going to prove this one because of our exam is MCQ type. The proof is not asked, so we are not going to explain the proof of this theorem. So remember, one important thing is that the equation m dx plus n dy 0 is said to be exact if and only if dA by m by dA by y equals to dA by n by dA by x. Okay. So we are not going to explain the proof of this one. Okay. So see the examples now. Here are the examples. How to solve such type of examples is that is solve. This is bracket means m dx plus n dy is 0. What is m and n? You can identify it easily. Check that is exact or not by using the theorem. That is the equation m dx plus n dy is equal to 0 is said to be exact if dA by m by dA by y is equal to dA by n by dA by x. Okay. So how to solve it is the solution of that differential equation. I will say it is directly. That is if equation is exact, then its solution can be written as y is equal to integration of m dx plus integration of n dy, that is the terms of n not containing x only. Okay, integrate that. Here is integration actually. Here is integration. Okay, here is integration. Integration of m dx and integration of the terms of n not containing x dy 0. So what is m and n? You know that n madhya asha terms घ्यायचे की त्यात x नाही अशा. Okay. So we get an integrating, we get a solution of that. Am I right? Okay. So see, equation is reducible to exact differential equation. It is asked in MCQs. That is, if m dx plus n dy 0 be a homogeneous equation in x and y, then its integrating factor is 1 upon mx plus ny. Integrating factor means a factor. If we multiply that factor to that equation becomes integrable. That's why we say this is the integrating factor. So m dx plus n dy 0 is homogeneous, and if we multiply this equation by 1 upon mx plus ny, that equation becomes integrable. That's why we say that 1 upon mx plus ny to be the integrating factor. Homogeneous means what? You know that. Okay. Now, second is if the equation m dx plus n dy 0 be of the form f of function of xy into y dx. function of xy into x dy is 0, then its integrating factor is 1 upon mx minus ny. Third is, if dou by m by dou by y minus dou by n by dou by x upon n is function of x, then integrating factor is e raised to integration of, this is e raised to integration of f of x dx. And it is function of y, then it is e raised to integration of f of y dy. Okay, it is in this way. So there are some examples सॉल्व करून दिलेले आहेत. तुम्हाला मी पीडीएफ पाठवली, ते पीडीएफ मध्ये तुम्ही बघा. काही शंका असेल तर मला फोन करून किंवा व्हॉट्सअप थ्रू विचारू शकताय. ओके. नेक्स्ट टाइप ऑफ डिफरेंशियल इक्वेशन इज द लिनियर इक्वेशंस. A differential equation is said to be linear if its dependent variable and its derivative occur only in the first degree, not multiplied together in this way. म्हणजे dy by dx plus py is q, p and q हे x ची फंक्शन्स असतील तर हे याला म्हणतो लिनियर डिफरन्शियल इक्वेशन. लिनियर का, तर या इक्वेशन मध्ये y हा डिपेंडंट व्हेरिएबल असतो. त्याची डिग्री, y ची डिग्री बघा 1 आहे, y रेज टू 1. dy by dx याचं डेरिव्हेटिव्ह त्याची डिग्री 1 आहे, म्हणून या डिफरन्शियल इक्वेशनला म्हणायचं लिनियर. लिनियर जनरली लिनियरचा अर्थ फर्स्ट डिग्री इक्वेशन असा असतो. ओके, ध्यानात ठेवा ते. Now how to solve we are not going to, but only what is the solution of dy by dx plus py is q, we have to remember that is y into integrating factor. One thing is integrating factor is e raised to integration of p dx. E raised to integration of p dx is integrating factor of this linear differential equation. So its solution is y into integrating factor is equal to integration of integrating factor into q dx plus c. So this is the solution of dy by dx plus py is q. Remember one thing is that, see, I want to write one equation here, that is dx by dy plus p into x is equal to q. Now see this one, dy by dx plus py is q. This is linear in y, we say, because y is the dependent variable. This is also linear and it's here dependent variable is x. So this is dx by dy plus px is q, and this is dy by dx plus py is q. Both are linear. या इक्वेशनला म्हणतो लिनियर इन y आणि याला म्हणतो लिनियर इन x. ओके. मग याचं सोल्युशन काय असतं, याचं सोल्युशन मी इथं लिहिलं नाही पण मी इथं व्यवस्थित लिहितो. या dy by dx plus py is equal to q. चं सोल्युशन काय, तर इट इज y into e raised to integration of p dx is equal to integration of e raised to integration of p dx into q dx plus c. हे याचं सोल्युशन आहे, याचं सोल्युशन हे आहे. मग याच्या बरोबर हे कंपेअर करा, मग याचं सोल्युशन काय येतं, तर इट इज x. ओके, दिस इज x. कोणतं इक्वेशन, तर dx by dy plus px is equal to q. दिस इज लिनियर इन x. त्याचं सोल्युशन काय, तर x into e raised to integration of p dy which is equal to integration of e raised to integration of p dy into q dy plus c. So you have to remember directly the solution of this linear equation. Okay. May be remembered as y into integrating factor is equal to integration of integrating factor into q dx plus c. Remember what is the integrating factor, is integrating factor is e raised to integration of p dx. This is very important one. This is the linear differential equation. So first order linear differential equation. There are the equations, differential equations solved here. You can see it as just the first example is given. X plus 1 dy by dx minus y is e raised to 3x into bracket x plus 1 square. So make this equation to the standard form as that is dy by dx plus p into y is equal to q. Make them standard, that is convert this equation to this form and identify p and q. So here p is minus 1 upon x plus 1, q is e raised to 3x into x plus 1. There is a square, but dividing by x plus 1, 1x plus 1 get cancelled. So p and q are in this way. Then find integrating factor. Integrating factor is e raised to integration of p dx is the integrating factor. Okay. So what is the integration of p dx? Find here. Then find integrating factor. So whatever may be the integrating factor in this one, calculate by using pen and paper. You will clearly identify this. That is, solution of this is written as y into integrating factor is equal to, here is integration. So integration signs are misplaced. That's why see y into integrating factor is integration of integrating factor into q dx plus c. Substitute what is the integrating factor and q. Again integrate, you will get the solution in this way. Okay. So let me take solve this. This is the exercise given. If possible, solve it. Next type of differential equation is the Bernoulli's differential equation. See, Bernoulli's differential equation is of the type dy by dx plus py is equal to q into y raised to n. Okay. Linear is dy by dx plus py is q. Here right hand side is q into y raised to n. This type of differential equation is called the Bernoulli's differential equation. P and q are functions of x only. So remember this is a Bernoulli's differential equation. To solve this equation, we make this Bernoulli's equation to be the linear, that is dividing by y raised to n. They take down 1 upon y raised to minus n to be the substitution, whatever be z, v, whatever may be. That equation transfers to the linear differential equation of this type. dz by dx plus p into 1 minus n into z is q into 1 minus n, whatever is that. So to solve this one, see, this is example here. This is example here. So see, this is x into dy by dx plus y is equal to x cube y raised to 6. जर इथं y raised to 6 नसतं तर ते लिनियर असतं. इथं y raised to 6 आहे म्हणजे y raised to n टाइप आहे, म्हणजे हे बर्नॉलीज आहे. बर्नॉलीज सोडवताना हे y raised to 6 ने डिवाइड करा. ओके, डिवाइड केल्यानंतर सबस्टिट्यूशन घ्या. जे 1 upon or y raised to 6 is something variable z, v, whatever may be. That equation becomes linear, and we know that how to solve the linear differential equation. We are not going to spend the time to explain this. So तुमच्याकडे ते totally आहे, examples दिले. So this is sufficient for you. Okay, this is a short video. Next time we start the next chapter, that is the differential equations of first order but degree higher than first. Okay, see you. Good day. Thank you.